Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be adding powers of I. We have I minus I to the fourth plus I to the ninth minus I to the power 16 plus so on and so forth all the way up to I to the power 225, which is 15 squared. In other words, we are adding powers of I that are perfect squares. And of course, the signs will alternate. So the odd perfect squares are going to be coming with a plus sign, and the even perfect squares such as 4, 16, 100 are all going to come with a minus sign. And I'll be presenting more than one method, and we'll also look a little bit behind the scenes. Let's get started with the first method. So when I look at something like this, it would be helpful to look at the first few powers to get a pattern. And most of the time, this is going to give you a nice pattern to work with. So I is I to the fourth power is 1, as you hopefully know, because I squared is -1. If you square both sides, you get I to the fourth equals +1. And that's very important because it's kind of like a cycle. Think about mod 4. The powers are all going to repeat. I to the ninth power is basically I to the fourth squared times I, or you can think of it as I to the eighth times I. And when the power is a multiple of 4, it's always 1. So this will give you I. So plus I with the I to the 16, we're going to get 1 again, but with a minus sign. So the pattern is basically I minus 1 plus I minus 1 plus so on and so forth. So we can think of this as pairs. And notice that I to the power 225 is 15 squared, and this is an odd number, so it is going to come with a plus sign. So the last term is going to have a plus sign, which means we're going to have an I minus 1 and then a plus I at the very end. And if you look at I to the power 225, it leaves a remainder of 1 upon division by 4. Therefore, it leaves a remainder of 1, which means I. Okay? Since we have an odd number of numbers, and you can kind of tell this is 1 squared, this is 2 squared, ends up with 15 squared, which means we have 15 terms. That's an odd number. So when you pair these up, you're going to have a leftover. Make sense? Now, here's what happens. This is I minus 1. This is I minus 1. We have a bunch of I minus 1s plus an I. How many I minus 1s do we have? Since we have 15 terms, there should be 7 pairs plus the I. So we have the I minus 1 7 times plus another I. That's going to give you 7I minus 7 plus I, and then you can write it as 8I minus 7. Now, you can also write this as -7 plus 8I in the most standard form, right? Okay, so that will be the answer pretty much, but notice that we can generalize this to any power. Let's say I goes to n squared, where n is any number depending on value of n. Of course, if odd or even, we can come up with a general formula as well. Now, obviously, as almost with every problem that I do on this channel, we'll check our results against Wolfram Alpha and see if Wolfram Alpha or AI can solve this problem better. And in this case, unfortunately, Wolfram Alpha is unable to determine the general term from these. Maybe if we gave it more terms, it will be able to. I didn't test it. You can go ahead and test it out and let me know what you think. Okay, so let's continue. Now, what's another way to approach this problem? Let's think of alternatives. I minus I to the fourth plus I to the ninth minus I to the 16th, all the way up to I to the power 225. Unfortunately, this is not a geometric series like I plus I to the third plus I to the fifth. Therefore, we can't use the formula. This is a little different. These are perfect squares. But again, pretty much we can find a pattern. Now, we can also separate these into odds and evens, like I plus I to the ninth plus I to the power 25, all the way up to I to the power 225. And then from this, we can subtract the even perfect squares, I to the fourth, I to the 16, all the way up to, since this is 15 squared, the last even power is going to be I to the power 196, which is 14 squared. And then we can go ahead and add each one separately. In this case, we're going to have an I, and then another I, and then another I. The question is how many terms we have. Remember, we are supposed to have 14. Was it 15? Okay, let's take a look. This is 15 squared. It starts with 1 squared, so there's going to be 15 terms, which means we're going to have half of 15 is 7.5. And since we do have more positive terms, the odd numbers are basically going to be 8 terms. So this should be 8 terms, and this should be 7 terms. Okay, so the positives are 8 terms, and each one is equivalent to I. Therefore, that's going to give us 8I, and then each of these is equivalent to 1. That's going to give us a -7. And again, write it in the standard form, -7 plus 8I. And think about how you can generalize this problem, because notice that 7 is half of 15, but 1 less than that, or half less than half of 15, and 8 is half more than that. Okay, so you can kind of figure out the general pattern, hopefully. Okay, great. So let's go ahead and take a look at this. Why is this giving us I all the time and 1, 1, 1 all the time? What is happening, even though these are perfect squares, right? So here's what happens. A number, when you have something like I to the power a perfect square, n is either even or odd, right? If n is odd, then n can be written as 2k plus 1. And when you square n, you get 4k squared plus 4k plus 1. Now here's the critical part. When you look at the remainder, mod 4, you can basically write this as 4 times. You could take out a k, but no big deal, since we're interested in mod 4 only. N squared is going to be 1 mod 4 when n is odd. Make sense? So this is our first case. The second case is when n is even. And when n is even, something similar is going to happen. You square n, it's going to be a lot simpler, 4k squared, and that's going to be 0 mod 4. Since an integer is either odd or even, you only have 2 choices for mod 4. So for example, if I had an equation like n squared is congruent to 2 mod 4, there is no integer that satisfies this. Or is there? Or if you n squared is congruent to 3 mod 4, again, we don't seem to have a solution, do we? Anyways, you hopefully get the idea. This is what's happening behind the scenes. That's why we're getting I to the power 0 and I to the power 1 from these terms, and alternatively, we're adding them to get the answer in the standard form. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.